I'm your host Dan Rojas, and I'm going to be talking to you today about the most widely used source of power in the world, electricity. Now, at face value, electricity can seem pretty simple. You turn a light switch on, it comes on, you spin a generator, you get power. In actuality, electricity is a little bit more complicated than that. If you ever talk to an electrician about your ideas of creating a green power source to power your house, they may not be as enthusiastic as you are about it. It's not that they're inherently negative about green energy, it's just that they deal with electricity on a daily basis, and they understand that to power an air conditioner, a hot water heater, or refrigerator requires an enormous amount of energy. So we're going to be discussing some of the basics today that's going to help you save tons of time in your quest of a green power source. We're going to start with voltage. This is a 1.5 volt direct current battery. This is a 12 volt direct current battery. This is a 19.2 volt direct current battery. Those lines coming into our house, they're 120 volt alternating current lines, stepped down by that transformer from those 20,000 volt high voltage lines. Now if you notice, the high voltage lines are thinner than the 120 volt lines, even though the high voltage lines are supplying energy to the entire neighborhood. Why? Voltage. Voltage is defined as the differential of electrical potential between 2 points when completing a circuit. This 19.2 volt battery has the potential of producing about 20 volts of electrical power. Right now it's not doing anything. If we take our battery tester leads and we attach it to the battery, we now complete the circuit and we have 20 volts of current. Remember I said those lines coming into our house were 120 volt alternating current? In actuality, they're about 124, 125 volt alternating current. It's varying a little bit because of the usage taking place in our house right now. Now, the power companies over the years have stepped up the voltage from what used to be known as 110 volt to around 125, 126, depending on where you live. They did this because houses now require much more electricity than they did in years past. So their option was A, install all new wiring to accommodate for the higher amperage, or B, raise the voltage a little bit. Electric motors in your house, like the one in your air conditioner, your refrigerator, operate fine on higher voltage. They actually can run up to around 140 volts before they start running into problems. They run more efficiently on that higher voltage. Compare that to lower voltage around 90, 95 volts and you'll burn a motor up right away. All of your electrical appliances in your house, from light bulbs to computers, can also handle the voltage fluctuations, so that's why power companies did that. Remember the high voltage wires running through my neighborhood? Well, they can transfer much more energy because of the high voltage. The higher the voltage, the more efficiently energy can travel along a wire. High voltage requires less current to accomplish the same load, so it faces less resistance, and less resistance produces less heat. Less heat equals better conduction. This fact about high voltage created the equivalent of a modern-day death match between two famous inventors, Thomas Edison and Nikola Tesla, and is the reason why most houses use AC power as their main source of electricity today. When we come back, I will explain amperes, direct current, and alternating current in detail, and give you some valuable pointers as to why DC power may be the best choice for your home generation power project.